All right, let's start talking about some right triangle word problems. 100% when you're doing these problems, you're going to need to annotate it, which means you're going to need to get all the information and turn it into a picture, and then from the picture, turn it into an equation that you can solve. So be very careful when you are setting up the picture, because if your picture is incorrect, it is highly likely that your equation will be incorrect. So let's see what we've got here. It says angle of elevation of a 16-foot ladder is 36 degrees. How far is the base of the ladder from the wall? Now, I am not an artist. I don't need you to be an artist. If you want to be, awesome. This is not going to be like, you're not going to be graded on your artwork. So we have a wall. We have the ground. The wall and the ground are 90 degrees to each other. And against the wall, we have a 16-foot ladder. So there's my 16-foot ladder. It says the angle of elevation of a 16-foot ladder is 36 degrees. So that means from the ground angling up, angle of elevation, this is 36 degrees. How far is the base of the ladder? So the base is going to be the bottom from the wall. We're looking for this edge right here, this bottom piece. So now that we've translated into a picture, from the picture, I want to translate into an equation. So here's my reference angle. I know this side's adjacent. I know this side's hypotenuse. So using those two pieces of information, I'm going to talk about the cosine of 36 degrees is equal to the adjacent over the hypotenuse. I am going to cross multiply to solve. So x is equal to 16 cosine of 36. Now I'm going to pop up Calculate 84 because that's the one I happen to have on my dashboard here. You can absolutely use Calculate 84. You can use Desmos. The only thing, make sure, I'm going to go into mode. I am in degree mode, so I'm good to go there. So 16 cosine 36 and enter. All right, 12.94 feet. So unless it says otherwise, round to two decimal places. I don't think it says otherwise. It does not. And absolutely 100% make sure you're using your units when you give your answer. Okay. All right. So problem number 1 is done. Problem number 2. Plane takes off at an angle of elevation of 12 degrees. All right. So here's the ground. Plane's taking off at 12 degrees. So this little thing is 12 degrees. How far has it traveled when it reaches an altitude of 5,000 feet? Okay, so altitude is going to be the distance from the plane straight down to the ground, forming a 90-degree angle. And this is going to be 5,000 feet. And it's asking how far has the plane traveled. Now, the path of the plane is this hypotenuse right here. So that's the part we're going to mark as X. All right, so just be careful about that. So based off of that, let's see, here's my reference angle. So this is going to be opposite over here. This is hypotenuse, which means sine. So the sine of 12 degrees is equal to 5,000 over X. Cross multiply, so 5,000 equals X times the sine of 12. I'm going to divide both sides by the sine of 12, of course. So sine of 12. And into my handy dandy calculator that goes, because that's not going to happen in my head. All right. So X is equal to 24,048. I don't think it says to round. It does not. 0.67 feet. Wanted to check my units there. All right, so problem number 2, all set up and done. All right. All right, number 3, from the top of a lighthouse, 150, I'm going to just start putting my picture in place. So there's my lighthouse. No, it's not artistic. I don't really care. Again, if you want to spend some time and, de-stress by drawing a lighthouse, you go for it. All right, so 159 feet above sea level. The angle of depression, so somewhere out at sea there is a ship. Oops, yeah, there's a ship, close enough. Now, what you want to be careful about is, what does it mean by angle of depression? All right. And angle of depression is, what I want you to think about is somebody sitting in the lighthouse looking straight out, just straight out. And they glance down, they depress their eyes, and they spot the boat. So this angle, let me make sure I got the right one. Yep, 19 degrees, is actually outside of the green triangle that I want to use. Now you have two options. You know this is a 90-degree angle here, so you can either do, this is also a 90-degree right here. So this is vertical and horizontal. So you could take 90 minus 19 and fill this angle in up here. Or if you remember a little about geometry, this top part that's the orange dotted line is parallel to the ground. So because they're parallel, these are actually alternate interior angles. So the 19-degree angle here and the angle here for the boat looking up are the same angle. So you could use that. It's really up to you. It won't matter one way or another with the math, but just make sure that you're not putting the 19 up at the top here unless it calls for it in the problem, but it doesn't in this case. So angle of depression is outside, all right? And you can put it down here as the angle of elevation for the boat looking up. It says find the distance from the ship. Well, here's my ship to the base of the lighthouse. Here would be the X. So I'm going to go ahead and use this as my reference angle. This is adjacent, that's opposite. And if we are talking about opposite and adjacent, we're dealing with the tangent function. So tangent of 19 is equal to opposite over adjacent. Do a little cross multiplication here. So 159 is equal to x tangent of 19. Divide by the tangent of 19. And into a calculator it goes. All right, so 461.77 feet. I'm just rounding out to 2 decimal places when I do this. All right, last problem for this video is going to be problem number 4. Okay. Tom is 100 feet away from a tree that is 35 feet tall. All right, so there's my tree, 35 feet tall. Here's Tom. He is 100 feet away. What is the angle of elevation of his sight line to the top of the tree? So angle of elevation is Tom is going to be laying on the ground here, and he is going to glance up and see the top of the tree. So this is the angle looking up that we're finding. So tree is going to be measured vertically. So that's a right angle. Let's go ahead and call that theta. So we have this handy dandy reference angle. We've got opposite, we've got adjacent. So the tangent of theta is equal to opposite over adjacent, which means theta is equal to the inverse tangent. Remember, tangent and inverse tangent will undo each other. So the inverse tangent goes into my calculator. 35 over 100. And that means that his angle of elevation is 19.29 degrees. All right, so the plan for Thursday for class is to take a look at any questions that you might have on 5, 6, 7, or 8 on this worksheet. I will put the answers in the key, but it's up to you if you have any specific questions about how to get those to make sure you ask them on Thursday in class.